Hey guys, just going to continue with looking at these last two problems on the friction worksheet. So, we have question 5. A boy pushes a 100 Newton crate forward with a 40 Newton force. The coefficients of friction are zero point 0.4 static, 0.3 kinetic. What will be the net force and the acceleration of the crate? Alright, so this is an interesting problem because we have a couple forces we have to deal with. First one, boy pushes a 100 Newton crate. So I'm going to just use this space up here. So we have a force of gravity of 100 newtons, which means we have a normal force of 100 newtons. Alright, pushing forward, we'll say to the right is forward because we like the right. Forward, 100 newtons. Force applied, not 100, at 40 newtons. Says it is sliding across the floor currently. Sliding across the floor. There's that key word that tells us that we are not in static friction. We are in fact in kinetic friction force, which is going to be a value of 0.3 times the weight, or really the normal force, which is 100 newtons. 0.3 times 100 is 30. So I have a kinetic friction force opposing me backwards, FFK, of 30 newtons. So, the net force, normal force and our force of gravity cancel out. My net force is simply total right minus total left. And my net force in this case is going to be 10 newtons to the right. And then I have to find the acceleration of the crate. Again, that keyword, I don't care about static because it's already sliding. I'm past that, I'm into kinetic friction. So my net force is 10 newtons to the right. I have to figure out what my mass is. Mass is weight over 9.8. So my weight is out there. My weight is 100. 100 over 9.8 gives you 10.20 kilograms. All I have to do to find the acceleration is do 10 newtons, my net force, over mass, 10.2 kilograms. And I'm going to get 10 over 10.2, which is 0.98. 98. That's going to be meters per second squared. Net force is to the right, means my acceleration is to the right. There you go. Alright, last question, question 6. You pull horizontally on a 300 Newton sled packed with presents, which is initially at rest. Coefficients are 0.4 and 0.3. You'll be able to move it. Will you be able to move it if you pull with 100 newtons? So to do that, we have to figure out, basically we're comparing and asking the true question, is our applied force greater than mu static times the normal force? If it is, then we are able to pull the sled from rest. So, well, we've got to compare. What's our mu s? Our mu s is 0.4. Our normal force is 300. Because it's 300 Newton sled, that's its weight. Its weight equals its normal force. So we have 300. Sorry for the noise, my dishwasher's running. 0.4 times 300, which is 120 newtons. I have 120 newtons. So if I'm pulling with 100 newtons, that's my applied force, and I'm trying to say if that is greater than my static friction maximum force, 120 newtons, it's not. That is not a true statement, which means that I am not moving. So part A is no, because 120 newtons is the maximum static friction force that can happen. I'm only pulling with 100. I need to break 120 in order to get movement. But part B says, alright, well, maybe we are already sliding. If we're already sliding, there's that key word. Sliding tells us that we have to look not at FFS, but at FFK. And FFK is the mu k, which is 0.3 times the normal force, 300, which is 90 newtons. So I'm pulling with 100. That's my applied force, or probably tension, either way. My applied force is 100 newtons. My friction force is 90 newtons, backwards. And then, of course, I have force of gravity of 300 and normal force of 300 newtons. So what's happening? Well, if the sled were already sliding and I was pulling with 100, I'm actually still speeding up because my net force is not in the same direction as friction. My net force, in this case, and this isn't part of the question, I'm just doing a little extra. My net force is 10 newtons to the right, just like in the previous problem, and I can figure out the mass. My mass is going to be 300, let's write that over here. Mass is the weight, 300 over 9.8, which is 30.6 kilograms. My acceleration, which is net force over mass, 10 over 30.6, gives me an acceleration of 0.33 meters per second squared. So I'm actually speeding up to the right at 0.33. If this sled were already sliding. If it weren't sliding and I was pulling with 100, I wouldn't get anywhere. I haven't broken that bond. This is not a true statement. I haven't broken that bond. My static friction force in that case would just be 100 newtons. I need to get, in order to get it even started moving, 120. But once it is moving, 100 newtons is more than efficient, or more than sufficient, because I only need to keep it 90 in order to even keep it just moving at a steady speed. If it's less than 90, it'll start slowing down. But I'm pulling greater than 90, which means I'm overcoming friction even that much more and making it accelerate. Making it accelerate by the net force, 10 newtons to the right, 100 minus 90, over the mass, 30.6, 300 over 9.8, to get 0.33 meters per second squared to the right. Great job. Hopefully this has helped you to understand this a little bit better. Please feel free to go back or to come into class tomorrow asking me some questions. All right, thanks.